Hello, everyone. Good morning, afternoon, evening. Dear
Good
authors
afternoon.
and invited guests, welcome to Technical Session 1C. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024. London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of Feb 2020, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd Feb 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 2 minutes for question and answer. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you to the chairs for this session. We have Professor Hanji Venasetan Rathel with us. Welcome, sir. Would you like to share any opening remarks with the participants?
Good afternoon, everyone.
Good afternoon, sir. Would you like to share any opening remarks with the participants?
Yeah, I don't hear you.
Hello, am I
I,
audible?
yeah, no, now, yeah.
Okay. Would you like to share
Uh,
any remarks with the participants?
yeah. I think we can start with the first presentation. I- Maybe I don't understand your points.
Okay, no worries. And we also have another session chair with us in this session, Sir Dr. Jitendra Bhatia, who will be joining us during the session. Now, without any further ado, let's start with the presentations. Uh, First up, I would like to request Sir Laurent Barthélemy to
Good
kindly
afternoon.
present his paper titled Berthing of Crew Transfer Vessels Against Offshore Wind Turbines, Kinetic Static Friction Calculation.
Okay,
You can
I'm going
start
to
the
share my
presentation.
screen.
Yes, you can share your screen.
Can you see?
Yes, it's visible.
Okay, I'm going to put it in a full screen. Can you still see it?
Yes.
Maybe I should duplicate my screen because I have an extended screen. That will make things easier. Sorry for that. Here we go. Can you see my screen?
Yes, it's visible.
Okay, fair enough. I will start like this. I am talking about problem of maintenance of offshore wind turbines. To visualize, on the left side you have a monopile, which is sunk into the seabed. On the right side you have a typical offshore maintenance boat, which is with two hulls, a catamaran. if you see from above, on the top right corner, you see on the left hand the monopile, on the right hand the boat, and in between you have what we call a fender, which is deformable so that it can cope with the motions of the waves when the boat reacts to the waves. Due to the confidentiality of ship hull plans, we had to bypass confidentiality issues by using a mathematical equation to model the ship hull, which is called the Wigley hull. Now we are going to look at the mechanics of berthing a boat against a wind turbine. How to get close and to allow the passengers to go to the ladder to climb up to the monopile. This model is made of several mechanical systems. The first one is a set of horizontal and vertical springs. What you see here is an elevation. So you see the hull from a side. Then you have a combination of horizontal and vertical dampers. So that this is not purely a spring motion. It is damped, so therefore there will not be any resonance. On top of that, you have what we call a vertical friction force. So you account for the friction of the boat fender against the monopile. Then if you put it into equations, so what you have here is the boat sea keeping equations with small motions, x being the horizontal ship motion, or surge, z being the vertical surge motion, or heave, and theta being the angular vessel motion, or pitch. And so you have an equation which is typical of mechanics, m times x dot dot plus b times x dot plus k times x equal an external force, which force is a combination of wave force, which is Fk, which is incoming waves, friction force, which is the boat which is vibrating against the wave. Then you have the mean ship propeller force, and then you have the spring forces. So the mean spring force at the fender, the mean damping force at the fender, and the variation of the propeller force.
Excuse me,
Sir, sorry to interrupt,
yeah.
but your slides aren't moving.
Sorry?
You're still on the first slide. Your slides aren't moving.
There was a delay. Correct? So I'm
No,
going on.
it is not the delay, I think. Maybe you can stop the showing and show again. Because you are still on this first slide.
So could you please share your screen again?
Yes, I'm going right to the slide.
Yeah, now it's moving. Fine. Yeah.
Sorry for that. Then you have the equation regarding the fender motion, which is the bit of rubber stuck between the boat and the monopile. That fender is attached in principle to the boat, but we are going to model a kind of independent fender which has its own motion. Its motion is dictated by the mechanical equation. So m star being the fender mass. Then you have the fender vertical acceleration. On the right side of the equation, you have the vertical friction force minus the vertical spring force minus the vertical damper force. Okay, let's go on. We can call then to make it simpler, an equation being Fkbx, which is the sum of the horizontal spring and damping force, and the same for the vertical force. Then you get into what you call a state space model. you are going to transform this set of second-order linear equations into a set of first-order linear equation by making a change of variables. So for those who are interested, please look at the publications. I can go into details for the PowerPoint. So if you look at this state space model, A is the matrix containing the unperturbed and uncontrolled sheet dynamics, which is without contact. F, so the second term on the right of the equation, is the vector of the boat against boat landing or monopile contact dynamics. So it includes the propeller force of the ship and the spring damping and spring and damping forces, sorry, and the friction force F. And eventually, EV is the vector of the perturbation forces, which is the waves, basically. So then you go on. This state space model can be modeled with the Simulink software, which is a utility which is associated to MATLAB software. It is a way to visualize into a sketch how to solve this set of equations. The results, are as follows. So what you have to consider is the above table, which gives a benchmark. Basically, we found another publication, which is independent from my work. It comes from a Norwegian ship architect firm. And they worked out that what rules the boarding of a boat is a combination of the sea state, so the significant wave height, HS, and the ratio between the wavelength and the boat length. The wavelength is the distance between two wave crests. So you see, according to the Norwegian reference, if the ratio wavelength over boat length is below 1.85, you may board the boat, the monopile, with the waves up to 2 meter significance. And if you have a wavelength over boat length ratio above 1.85, you can only board with 1.5 meter significant wave height. Why? Because the boat is a little bit like a cork, so it floats up and down at the same time as the waves. It moves more. Then the middle table is a presentation I did with ICICT as well, so your conference site, 2 years ago, which was with a simplified linear model, which is called a pseudo-kinetic friction model. I already worked out that from the reference, the Norwegian architect, I do not get 1.85, but 1.76. And with this new calculation, which is assuming a non-linear model, so accounting for spring and damping forces and friction, this 1.76 get into 1.80. So the conclusion is that this presented nonlinear calculation meets the wavelength boarding criteria from a Norwegian architect with a -3% accuracy and +2% compared to my previous calculation with ICICT. So the next step for my work will be to account for an irregular wave, which is not a sinusoidal wave, but a random wave with a random crest and troughs coming during the boarding of the boat. So that is the end of my presentation. I am open to questions and answers. Thank you for listening.
Thank you very much for your presentation.
Thank you.
I have one question.
My pleasure.
Mainly about the results. Could you explain us the approach of the work from the reference one?
Yes. So what you have to consider is that a boat does not react necessarily in phase with the waves. That is quite simple. The smaller the boat is compared to the waves, the closer it is to the motion of a cork, of a piece of wood which is going up and down with the waves. While on the other way around, so if the boat length is much bigger than the wavelength, well, the boat does not react instantaneously. It will react with a difference in phase. So its motion will be slightly decayed. There will be a damping, so it will move less basically. So that is the main thing. This is from a maritime point of view. A boat will not react on the same manner depending on the ship length to wavelength ratio. Thank you for your question.
Thank you, sir. Are there any other questions? Okay. Uh, Moving
Thank
forward,
you.
yes, thank you so much. Before moving forward, we have our second chair for the session with us as well, Dr. Jitendra Bhatia, sir. I welcome you to the session, and I would like to take this moment to give an introduction to both our session chairs to the participants. Uh, the first session chair for this session is Professor Hanji Vinasetan Rathel. He is currently the assistant professor of Keynes Universities in Artificial Intelligence. With solid experience in his field, his expertise is illustrated through his concrete achievements in various fields such as agriculture, finance, tourism, and his continued commitment to promoting useful and responsible artificial intelligence. A teacher and researcher in artificial intelligence and president of the Foundation, Rathel, for Responsible and Efficient AI. We are grateful to have you with us today, sir. The second chair for the session, Professor Jitendra Bhatia, is currently Associate Professor at Nirma University, Ahmedabad, India. He has more than 16 years of teaching experience at undergraduate and postgraduate level. He has published and presented a number of papers at reputed international and national level journals and conferences. His main research interests include protocol design for intelligent transportation system, software-defined networking, vehicular networks, and cloud computing. Thank you, sir, for joining us for this session. And yes, uh, moving forward to the next presentation for this session, we have Sir Philippe Canonja with us. Sir, I would like to invite you to present your paper titled Comparative Study of Machine Learning Algorithms for Indoor Location based on Wi-Fi Fingerprinting according to User Postures. Are you here, sir?
Good morning, good afternoon. It's Mariam Nya, co-author
Yes,
of
ma'am.
this paper. I'm going to present this paper.
Sorry, I didn't get you.
I'm going to present this paper. Can you hear
Okay,
me?
okay. Yes. I can hear you. Please start your presentation.
Can you receive my screen?
No, I cannot see your screen.
Because when I share, I don't see my screen. Can I send you just the presentation, this presentation on email or?
Ma'am, you can share your PPT in the chat box to me, and meanwhile we can take the next presentation. So after that,
Okay.
I'll present your PPT on behalf of you, so you can present the
Okay.
paper, right? Okay, yeah.
Okay.
Priyanshi, we can take the next presentation.
Yes, just a second. I'll present my screen. Okay. So moving forward, I would like to invite Sir Vinayak Tangsal to present his paper titled Cyber Threat Hunting Using Large Language Models. Do we have you with us, sir?
Yes, good morning, good afternoon, good evening.
Good evening,
Can you
sir.
hear me?
Yes, I can hear you. I'll stop sharing my screen so you can present yours.
Thank you.
Yes, your screen is visible.
Okay, so, and you can hear me as well, right?
Yes.
Okay, all right, well, thank you again. Thank you for letting me present. It's nice to be here and looking forward to the other presentations as well. I am going to be talking about my paper titled Cyber Threat Hunting Using Large Language Models. I'm an assistant professor at Ball State in computer science. And this paper essentially introduces this idea of cyber threat hunting, which has been something that enterprises and companies have been doing for many, many years, but using what we now call traditional techniques. And what I am proposing over here, again, this is a concept paper, is how to use large language models, which have been developed over the last 5 years. Obviously, examples include Gemini, Bard, and similar ones, or ChatGPT, the more popular one. But how do you use them in this area of cyber threat hunting? Are my slides progressing as well through to the next one?
Yes.
Okay, all right, just making sure. Thank you. So cyber threat hunting, again, it is a proactive approach. Again, regardless of using large language models, it is a proactive approach to cybersecurity that focuses on actively searching for and detecting cyber threats that may have bypassed traditional security defenses, such as firewalls, intrusion detection systems, port forwarding measures, and so on. Cyber threat hunting involves analyzing literally vast amounts of data, identifying anomalies, and investigating potential, what we call IOCs, or indicators of compromise. Indicators of compromise, or IOCs, are pieces of evidence or artifacts that suggest an intrusion or security compromise within a network or a system. Large language models, again, most of us are familiar with the Gemini, the ChatGPT, and the other ones. So these LLMs have the potential to enhance cyber threat hunting by augmenting the capabilities of human analysts. LLMs can assist in automating the analysis of security logs, application logs, any other type of general computer logs, parsing and understanding threat intelligence reports from repositories like the CWE or the CVE or OWASP and so on, as well as identify patterns or linguistic markers that may indicate malicious activity. We talk a little bit about the significance of cyber threat hunting and why it is important to organizations, companies, and enterprises. It enables companies to detect and respond to threats before they can cause significant damage. So you are looking for the threats before they occur or before they happen. This is like your intrusion prevention systems, which also these days are built using machine learning models. What I'm proposing over here is taking large language models and being able to effectively, with a low error rate, predict what are the threats that are possibly on the horizon. Cyber threat hunting also reduces the dwell time and helps organizations prepare and have a better business continuity and a disaster recovery plan in case an event, a cybersecurity event actually occurs. And one of the main problems in cybersecurity is that the malicious actors are always a step ahead of everyone else, coming up with the latest and greatest threats to cybersecurity. So cyber threat hunting does empower security teams to try to stay one step ahead, or at least at par with the adversaries and malicious actors, to protect critical systems and sensitive information. On to the next slide. Talk a little bit again about how LLMs, large language models, can be used to in this process of cyber threat hunting. As I mentioned earlier, cyber threat hunting has been done for many years. The LLM approach is a newer way of being able to analyze threats at a massive scale. So all of us are again familiar with different types of data analysis techniques like classification, clustering, the traditional ones from machine learning. What LLMs can do is augment those techniques by basically learning from past data as well as vast amounts of data. The strength of LLMs is essentially in their capability to learn from massive amounts of data and data that may not be as correlated to traditional statistical techniques. So LLMs can analyze and understand, as I said in the last slide, vast amounts of textual data. Give you a perspective, again, any application log or any network log for a medium-sized organization of about 500 employees on a daily basis is about 50 to 70 gigabytes of data. If that amount of data, current network security countermeasures only analyze part of it because of the enormity and the volume of the data. But with a large language model, the training, even though it might take time, the LLMs are built to be able to analyze and understand vast amounts of just plain log data, textual data that includes threat intelligence report. So you can see it, they can analyze it from multiple sources, external sources, internal sources, even online discussion boards, and so on. LLMs are getting better depending on the training at identifying patterns that cannot be discovered by traditional machine learning techniques. And they can also provide contextual information rather than just a linear temporal output. They can also provide contextual information based on a lot of other factors in coming up with these indicators of compromise. A little bit more on how log analysis and anomaly detection can be bettered with large language models. They can understand, LLMs can understand log entries, patterns, and any deviations from normal behavior. They can be trained to establish baseline behavior, as well as in real time manipulate the threshold if you're doing anomaly detection or intrusion detection based on threshold based techniques. So no matter which way you are doing anomaly detection, be it profile based, wherein a normative profile is established, or be it attack based, in either approach, large language models can help make anomaly detection a lot better. LLMs can be trained on diverse log data sets, so diverse as in coming from the database, from the network, from the operating system, and so on. And one of the practices that security teams engage in is called penetration testing, as well as threat modeling. Threat modeling is where you model potential threats. So just like how you can ask large language models to generate text based on their learning, you can also ask large language models to generate synthetic log entries or not artificial, but attacks that are based. So ask them to generate attacks that are based on their learning, and then use those attacks to do penetration testing, threat modeling, and similar other activities. Indicators of compromise. So to ensure the effectiveness and quality of LLM-generated IOCs, obviously careful training and fine-tuning of the models are essential. LLMs can be trained on diverse data sets, including historical attack data, threat intelligence reports, and security logs to learn the parameters and characteristics of these IOCs. And especially if you can train them with domain-specific data, you can enhance their capabilities. For example, going back again even to that earlier slide, LLMs can process and interpret various amounts of data and be able to predict what may happen in the future. Threat intelligence analysis. This is again vast area, vast in terms of the amount of data that you have to look for. What are current zero-day attacks? What are attacks that are being that are occurring currently? So again, with their prediction capabilities, LLMs can also help with threat intelligence analysis as well.
This is a
Obviously,
great
they need.
10 minutes reminder.
Thank you. Just 2 more slides, almost done. So perfect on time. Thank you. So towards the end here, the evaluation of such systems, if LLMs are indeed trained to do cyber threat hunting, obviously the usual scores that we use of sensitivity, specificity, precision, recall, and F1 score are evaluation metrics. Those come from your confusion matrix, classic statistical based ones. With LLMs, there is one thing called fidelity, clarity, and relevance. And those are essentially metrics that are specific. So fidelity again measures the correctness specific to the LLM prediction, generation of those IOCs, the clarity and how relevant they are, because LLMs to start with do generate slightly more false positives or unclear outputs. So interpretability is an evaluation metric. Adversarial robustness, that's where how robust the adversary is and what it can do or cannot do. How does the LLM respond to that in real time? And then bias and fairness is also important to make sure that, again, they are not biased and are fair. And then the other metrics relate to the efficiency of the LLM. I'm going to stop right here and then open the floor if anyone has any questions. Again, thank you everyone for your time.
Thank you very much for your presentations. I think that it is a very interesting topic. I, I, I have one, maybe two questions for you.
Go ahead.
So yeah, according to you and the state of the art of LLM now, which LLM do you use, for example, for this kind of task?
I have been using, as I start the experiments, and I'm about 3 months into it, I've been using Bard, P-A-R-D, Google's LLM to do this. They now call it Gemini as of last week, I believe. But that's the one that I've been using to run experiments.
Okay. But in practice, how do you evaluate, for example, the interpretability part? How do you evaluate the performance?
You can evaluate it by comparing it against traditional cybersecurity countermeasure techniques, or you can also, well, not or, and you can also evaluate it against the predictions in a non-cybersecurity world as to, given an LLM, how good it is at predicting cybersecurity threats versus how good it is at predicting the same exact model with different train data, how good it is at predicting this natural languages and any other domain, and do those comparisons as well.
Okay, thank you very much.
Good
Thank you.
afternoon, Jack. Can you hear me?
Yes, yeah.
Yeah, this is Laurent. I
Yeah,
wanted
I can
to
hear you.
know, thank you. I wanted to know if a large language model can also help predicting the trend in the future cyber attacks, a kind of derivation, you know, like on a curve when you do a derivation to predict the future. Will you be able to predict a trend in the kind of cyber attacks we could
I believe that
say?
is, yeah, I believe that is possible. Uh, uh, Eventually, like I said, work in progress. But right now, I'm able to at least generate what we call these. I mentioned as indicators of compromise. Hopefully, well, not hopefully, I'm fairly certain that the natural extension of that would be predicting based on an extrapolation or a curve future attack.
Thank you.
Thank you.
Thank you, sir, for your presentation. Uh, I would now like to, just a second. I would now like to invite uh, ma'am again for her presentation. Ma'am Mariam, are you here, ma'am?
Yeah, I'm here.
Okay. Anisha, can you just present the PPT?
Yeah, sure. I'll do it.
Thank you. You can start your presentation, ma'am, as soon as the PPT is ready. Yes, we can see the PPT, Anisha.
Okay, thank you. My name is Mariam Nyon. I'm going to present my paper, compare study use machine learning for indoor localizations with, the University of Cheikh Anta Diop in Dakar, Senegal. And this work is done with the collaboration with the University of Franche-Comté in France. Okay, can you move to the next slide? Can you hear me?
Yes.
Yeah, can you move to the next slide because I do. Okay, here you have the agenda. Firstly, we have the introduction and background. Secondly, we have problematic of our works. And thirdly, we have the machine learning algorithms that we are using. And fourth, the experiments. And at the end, we have the comparison of the machine learning algorithm using user perceived and the summary of our works. Okay, can move to the next. Can move to the next slide.
Yeah, I've already moved to the next slide. Is it visible, right?
Yeah. Okay. With the development of mobile networks, a market for localization by service had emergency. And this localization by service give an information by the navigation using global positioning systems for observations and application-based localizations. The particularity of this location-based service is that the user are automatically located and don't have to report their position. And this, however, this exploration of the location-based service makes the location more and more difficult. For that, we have outdoor localizations. Global positioning system is the most technology used in outdoor localizations in open area, and it allows us to obtain a total accuracy from satellite by using a small and inexpensive ships. However, global positioning system doesn't work perfectly inside closed area, as the signal is affected by buildings, which lead to a decrease in the accuracy. And GPS need a lot of satellite to work perfectly. For that, can you move to the next slide? Can you move to the next slide? Next slide, please.
Ma'am, I've already moved it to the next slide. I think there might be some connection issues from your end. That's why it's getting delayed.
Sorry. This is why alternative location solutions are being studied. You have here indoor localizations. They used to enclose environments where signals are less accessible for GPS. And for that, we have a lot of technology like Wi-Fi, like Zigbee, like Bluetooth Low Energy. However, this technology have current limitations like sensitive to multipath effects, require some installation of additional hardware or software, and limited budget runs. For that, in our project, we use Wi-Fi. Why we use Wi-Fi for indoor localizations? Can you move to the next slide? Next slide.
She's already on the next slide, ma'am.
Okay. For that, in our project, we use Wi-Fi. Why we use Wi-Fi? Because Wi-Fi become a promising choice for indoor positioning as the only existing and established infrastructure to localize the mobiles and stationary users in indoor. And in Wi-Fi, we don't need to have specific equipments, and signal are available for indoor localizations, and it gives us a good accuracy. For that, we have many of a lot of technique is used in indoor localizations, but in our work we propose to use fingerprint. We have in fingerprint here we have two phase: the online phase and the offline phase. In the online phase, we collect the RSI value from the access points and send this RSI value as our database. And in the online phase, we use the RSI value on no location, and also we use algorithm to localize our positioning system. Why we use a fingerprint compared to other technologies? Fingerprint, we can do a localizations in loss without we can use in building which have multipath effect. We can use fingerprints in all indoor environments, and it adaptable to different indoor environments, and the cost of the infrastructure is low. However, building the fingerprint database is relatively expensive for each environment. If the environment change, the fingerprint change. For that, we use machine learning. Why we use machine learning? Because machine learning is the right approach to learn from observation without coding complex and secure network protocols. And machine learning can adapt to our different indoor environments without the need for calibrations or extensive manual adjustment. And machine learning can help us to provide real-time or near real-time localization to results, which is important for application requiring fast response. Next slide, please. Okay, here we have some machine learning algorithms that we are using here. We have used random forest, we have used extreme gradient busting, we have used continuous network and super vector machine learning algorithm. Why we use this machine learning algorithm? Because when we have data imbalance in our data, like here, we can use random forest to resolve these problems. Next slide, please. And here in our machine learning algorithm, we use, for random forest, we use a number of estimation as an input value, and the range varied from 2 to 1000 estimator. As this number increases, the accuracy improves until it stabilizes at 100 estimator or more. Above, we have the same accuracy. Random forest define a function fit such as SVM. Here we have the area of our location for indoor localizations. We collect the data from 4 access points here and containing the RSI value at each reference points using a mobile application called Wi-Fi fingerprints. And our area is here, 200 meter rooms in the numerical building from the laboratory FEM2 stay. And for each point, we carried out a regular and reproducible real test scenario. A point was taken every 50 centimeter interval on the x-axis and 50 centimeter on the y-axis, as you see in this figure. And we run several scenarios depending on the user posture. Here we have for the positioning the phone in the left on ear. Secondly, we have posture with the phone on the in front and posture with the phone on the back left. And we have also used the posture in the phone in the stool. Here we have the phone on stool horizontally and the phone on stool vertically. Next slide. Okay, here you have some hardware that we are using for our indoor localizations. For the implementation, firstly, we have the online phase. Here we collect the RSI value from the access point at each reference point using Wi-Fi fingerprint applications. And this collected RSI value from our database and are stored in a CSV file for use in Python. In the online phase, we use an ESP to read the RSI value with unknown reference point with unknown locations. And these values were stored in the Firebase database and use Python to access to the database. And also we apply our machine learning algorithm and estimate our positioning for locations.
This is a gentle 10 minutes reminder.
Okay, next slide. Here we have the performance evaluation. To evaluate our performance of our result, we use the minimum least square error to compare the real positioning and the estimated positioning. Further, we have for the first scenario of test, we divide our data in 70 for training and 30 for testing. Here we use Kaizen algorithm. For Kaizen algorithm, we took the car value as the input and test it. It shows us how it affects the MMSC. As a metric to evaluate the performance, it has a predefined function called fit in KNN, which also takes the RSI and the reference as important. And also we have for Israel, we use the radial-based models as an input to the classifier because its localizations power. It also has a fitting function that has used to build the machine learning models. As with KNN, it is necessary to modify the data format for the fitting function work. We have also the random forest. For the random forest, we use a number of estimator as an input, and the range varies from 10 to 1000 estimator. As this number increases and the accuracy improves until it stabilizes at 100 or more. Above, we have the same accuracy. Random forest define a function fits such as like KNN and SVM to create machine learning models, and also the format of the data is changed. We have also hexagram
Sorry
gradient
to
busting.
interrupt, ma'am. I would like to request you to conclude the presentation as you have completed the 12 minutes mark.
Okay, okay. Now we compare our machine learning algorithm for user who have the phone in the left on ear and we have in the left in front of you. Here we see for in the front of left of ear, we see that Kaizen gives the better results, and in front of you, when the user takes the phone in front of him, we have here the SVM give a best results. Next slide. Here we have also the phone in when the user takes the phone in pocket. Here we see that KNN is also the good result. And when the user have the phone in left on hand, we see that SVM gives the better results. Next slide. Okay, here we have the phone. When we have the phone installed horizontally, we see that Skyline give also the best results. And when we have the phone installed, we see that SVM gives the better results. SVM give random forest gives a better result for the phone in the stool. And we can conclude that. Next slide. For the summary of our work, we see that using machine learning algorithm can improve the accuracy for indoor localization, and also use machine learning for machine learning and fingerprint using Wi-Fi signals. It is also give us a better result. And also it is important to take a lot of criteria or comparison. For example, in our next our previous paper, we compare how is to reduce the noise in the network, because it is also important to take account the posture of the user and to see how is the localization when the user have in different same posture. For our next, for our outline, we use a Wi-Fi registration using on mobile applications, and using also angle of arrival, and also using machine learning, deep learning, and use also MIMO concept for indoor localizations. Thank you.
Thank you, ma'am. Uh, are there any questions?
I have one question. I am not at all a specialist into that domain, Maria. You need to have a mobile phone in order to use this Wi-Fi fingerprinting technique. I understand this is for security applications in order to be able to locate someone into a confined space.
Yeah. For that, we have on mobile applications called Wi-Fi fingerprint. And firstly, we collect the RSI value and in the online phase, and in the offline phase, we also collect the RSI value of the unknown location, and also we apply machine learning to localize to estimate our positioning systems.
Thank you, that is clear.
I have one concern here. So I hope I'm audible.
Yes, sir.
Yeah.
So basically, this is related to localization or more of a security work?
It is related to localization, but we can use it in indoor area, many of indoor area like buildings, hospitals, any area we can use this.
Okay.
This system
So
model.
have the authors have done any time estimation that how much time it is taking to give you localization weights or coefficients? How much time it is taking for one localization or one fingerprinting?
Okay. For one fingerprinting, for example, we compare for the traditional fingerprint and now fingerprint using machine learning, we reduce the time to mark it. We have more than less time to do the localizations.
Okay, thank you.
Thank you, ma'am. Moving up next, I would like to
Sorry for
invite.
mistakes.
Sorry.
I'm sorry for these mistakes, like my.
No worries, not. Yeah. Moving forward, I would like to invite Sir Nathaniel Selavo to present his paper titled Energy Detection Based Measurement and Analysis of Spectrum Occupancy for ADHOC Cognitive Network Research for Federal University of Technology, Lena, Nigeria.
Okay, good afternoon, everyone.
Good afternoon, sir.
Thank you. Please, can I share my slide?
Yes, you can.
Okay. Sorry, be patient, please.
Sorry?
Be patient. The slide is loading.
Yes, no worries.
Can you see now?
Not yet.
Is it there?
No.
Can you see it now?
No, it's not visible.
Okay, I can view from my end. Is it there?
No, it's not.
Wow.
You can share the screen in Zoom.
I have shared the screen.
It's not visible.
Is it there now?
No, sir.
The screen is shared.
Sir, kindly resolve this issue from your end. And meanwhile, we can take the next presentation as the session is getting delayed.
Can you see it now?
No, sir, it's not visible. You can solve the issue at your end. Meanwhile, we will take the next presentation and then take yours after that.
Okay, do I send it to you?
Yes, you can share it with me in the chat
Let,
if you would like.
let me try to share again.
Okay. Meanwhile, I would like to request. Sorry.
Can you see it now? No.
No. This is my.
I have tried to share.
I have not received your presentation. Anisha, can you? Yes, it's now it's visible. Now it's visible.
Is it there now?
Yes, it's visible now.
It's visible?
Yes. You
Okay,
can
thank you.
present.
I should go away with the presentation?
Yes, please.
Oh, okay. Good afternoon, everyone. Can you hear me?
Yes, you're audible.
Oh, okay. My topic is, the title of my work is Energy Detection-Based Measurement and Analysis of Spectrum Occupancy for Ad hoc Cognitive Radio Resource for Federal University of Technology, MENA, I'll be delivering this under the following contents: introduction, problem statement, cognitive radio technique, system model, results, and conclusion. By introduction, we have the following radio frequency spectrum allocation in Nigeria. We have very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, and super high frequency. And the various kilometers are given in terms of distance and what they are designated for. And the problem statement, wireless connectivity on campus is a big problem because there are so many devices that are interconnected in the campus. Allocation of this scarce spectrum in the growing wireless connectivity is a critical challenge that needs to be managed or solved. Then the key to solving this problem is spectrum management. The study of spectrum management occupancy to identify the availability white space for cognitive radio in FUT MENA main campus was done in this work to solve this problem. There are three major cognitive radio techniques to look into in order to solve this problem. The first one is match filter detection. The second one is cyclostationary feature detection, and we have energy detection. But among all these, we decide to use the energy detection. But before the energy detection, the match filter detection simply assigns spectrum to primary users using pilot signal values that are fixed to the primary signal values, while the cyclostationary feature detection utilizes spectral coloration to detect and allocate spectrum to the primary user. Then the energy detection, which is our interest, detects the energy level of the received signal, compares it with established threshold value, and assigns spectrum to available primary user. And we have the system model. We have the ideal interference model, and we have the generalized. But in this case, we use temperature interference in energy detection to measure the size of white space in spectrum resource at the main campus, Federal University of Technology, MENA. When you consider the PU power of all the nodes connected, the Gaussian noise is given by the equation 1. And for the power received with respect to bandwidth, it is also modeled in equation 2. Then the temperature limit, if it is considered, then the equation 2 becomes what is modeled in equation 3. With respect to the power, the number of times a channel is occupied within a given period is determined from equation 4, which happens to be the duty cycle, and that is our major concern. Then the methodology was simply done by using the measurement, by taking measurement of the received signal strength of the study area, then plug it into the system model, which we have said. We use the energy detection method, and we now came out with the ad hoc cognitive radio white channels. From the results obtained, we try to measure from 3 selected areas, and the 3 locations over about 1,000 meters from the base station within the study area were considered. And the results of location 1, which is the blue, location 2, which is the brown, location 3, which is yellow, is showing. And again, the vertical axis is the received signal strength, while the horizontal is the distance from the transmitting antenna. It's seen that at location 3, the result from location 3 is much lower when you compare to that of location 1 and location 2. Then you have the channel occupancy. We use spectrogram to determine the mean channel occupancy over the duration of the period, and the result is shown also. We equally use the maximum channel occupancy over the duration. We try to calculate by using the spectrogram, and the result is equally shown. Is the channel occupancy bandwidth, and in conclusion, in this study and in the investigation of the spectrum resource of the selected campus area of the Federal University of Technology in Mina has been done. We understudied the frequency spectrum between the range of 2.3 gigahertz and 2.5. And from our study, the 2.409 gigahertz, 2.5 gigahertz spectrum was least utilized, and 2.409, while that of 2.46 is the most utilized. There exists available white space over 2.4 to 2.5, and the study will guide the deployment of cognitive radio for spectrum resource allocation on the campus thereafter. Thank you. Are you there?
Yes, sir. Thank you, sir, for your presentation. Are there any questions?
I have one question. Good afternoon, Nathaniel.
Good afternoon.
This is
Thank you.
Laurent. Coming to the conclusion, how is the university going to allocate the bandwidth for the university, under which decision-making process?
Please come again.
Yes, how is the university in Niger State, for instance, going to allocate
the university
selected bandwidth?
I can't hear you clearly, please.
So I am going to put the question in the chat. Okay.
Okay. Thank you. Thank you.
So let me find the chat. Where is the chat? Yes. Okay. So
yeah, I'm there. I'm there on the chat, please.
Here you go.
Yeah. How is the university going to allocate the bandwidth to the students? Hello. The university is not in charge. The study actually is not meant for the university to allocate bandwidth to students. However, it is an advice that actually there could be a white space for the free bandwidth that could be used for future allocation in terms of any eventuality. Because in Nigeria, we have bodies that actually allocate and in control of bandwidth allocation.
Yeah, that is clear. I understand. Okay. Thank you.
You understand? Okay, thank you.
Yes. There's a body which is in charge.
Thank you.
Thank you for your presentation, sir.
Thank you very much.
Moving forward, I would like to request Ma'am Cecilia Zamudio Beltran, to present your paper titled Experimental Vision Controlled Quadrotor Trajectory in Restricted Environments. Are you here, ma'am?
Yes, I'm here, and it's okay, my name.
Yes, I'm really sorry.
I
I'll
cannot
stop.
start the screen share. I don't know why.
Just a second. Yes, you can share the screen now.
Thank you. Yes. Can you see my screen?
Yes, your screen is visible. You can start the presentation.
Thank you for the presentation and the time. I tried to do my presentation fast. This is a work developed at La Salle, Mexico, and the motivation is that increased fascination with the capabilities of drones and their adaptable applications. And drones used for various tasks like remote access, search and rescue, I guess is the most important, volcano monitoring, structural inspection, and border surveillance. It's another that for me is the most important. For rotor drones, very affordable cost. We can have access for these prototypes. And Precise positioning and orientation data are essential, obtainable from sensors like inertial navigation systems, inertial measurement system, global positioning system, and others. Vision systems also play a crucial role by providing valuable information about nearby objects and improving environmental awareness for good navigation. And the objective of this project is improve the performance of a quadcopter by reducing the onboard processing load. It's because very delays and improving the accuracy of trajectory tracking using an offline vision system, a vision system on ground. This achieved by calculating the optical flow to determine the desired trajectory through the detection of a line, and then implementing real-time control over the aircraft using the processed data from a ground station. The dynamical model, well, these equations are obtained after applying the Euler-Lagrange method. Well, we have the position of the center of mass. We have Euler angles for z axis, y, and x. We can see the scheme of the quadrotor. We have for rotors, we have the moments of roll, pitch, and yaw. And this is the equation that we are obtained with Euler-Lagrange method. The control inputs, U and taus, are the total thrust or collective input, and the new angular moments. We can set the control of altitude as we can see in the equations, and the constants A's are positive, and Z sub D is a positive constant representing the desired altitude. For X, Y, and Z accelerations, we have this with some assumptions. And the control of yaw, we choose these equations. This is a well-known control, nested saturations. And the input of tau sub phi, which represents 4 integrators in cascade, and the control input is given by this equation. We can see the 4 integrators, and using the same logic, using the same assumptions, we have tau sub theta, as we can see in this equation. And also for the definition of optical flow is an approximation of the local image motion based on local derivatives in a given sequence of image, and is described by this equation where we can have the spatial intensity gradient, the image velocity or optical flow of pixel, x and y, and the 2D motion constraint equation. So we have a problem because this is an equation that is not possible to determine since it is an ill-conditional problem. So the problem of computing full image velocity then becomes the one of finding an additional constraint that yields a second different equation in the same unknowns. For this, we used Lucas-Canat method. That one is the one of the most popular algorithms currently known, and is very well and work for computing optical flow. The Lucas-Canat detector is a gradient-based displacement detector and is the basis of many image pairing algorithms. It does not give an excellent solution, that is important, but a relatively good approximation. Lucas-Canat supposes a locally constant flow in a small spatial neighborhood omega and proposed a solution using weighted least squares. And we also used, obviously, the pinhole camera model, describe how 3D points correspond to their 2D projections. And we have the projection center, a C, as the origin and the image plane, C equal F, representing the distance, the focal length, between the project center and the image plane, as we can see in the image. For the implementation, in this study, a high-definition webcam with autofocus was used for the real-time image capture, and image processing employed the OpenCV library, initially implemented a red line identification algorithm that you can see at the left side. Subsequently, the Lucas and Canat algorithm calculated optical flow on scene points using an iterative Gaussian pyramid approach or calculate the velocities. Key characteristics of the prototype include an autonomous flight time of approximately 15 minutes, a prototype weight of 350 grams, and with the batteries, we addition 250 grams. The drones span a depth of 30 centimeters, including the landing gear, with a maximum length of 75 and blade diameters measuring 30 centimeters. For the results, we can observe this, in this image, we can observe the successful line detection into image that is at right side, exemplify the optical flow detection computed on the red line by the green arrows. Obviously, this improved the calculatings, which provide the velocity in X and Y. And for velocity data collected from the UEMU are observed, we can observe that although the line detection has a good performance, when the optical flow calculation is implemented, the vehicle stabilization improves. In case of the velocity, in the acceleration, and also the altitude signal, we can observe less oscillation for the quadrotor. And well, the project improved the quadcopter's performance by reducing the onboard processing load and increasing the accuracy of trajectory tracking through the implementation of an offline vision system. This approach also contributed to its overall efficiency in navigating predefined trajectories with greater precision. And well, we applied a nested saturation nonlinear control strategy to achieve the aircraft stabilization and positioning. The vision system processes image in real time to identify and follow a defined red line. Then the speed of the image in the axis X and Y is calculated by means of the optical flow, and the real-time experiments have shown an acceptable performance of the prototype. As future work, we need to do some changes. The first, use of deep learning algorithms to estimate image velocity through optical flow. Maybe this also we need to change the controller We have to exploring more robust algorithms, use more sensor or another sensors, improve the experimental platform, and experimental testing in semi-controlled and non-controlled environments. And thank you very much.
Thank you, ma'am, for your presentation. Are there any questions?
Cecilia, can you hear me?
Yes.
This is Laurent Barthélemy.
Yes.
Okay, I am not into the aeronautic system or even a drone system. I am more into the maritime system. What I understand is that you need to have a very quick reaction time to adjust the trajectory.
Yes.
So what's time? Which reaction time do you achieve with this vision controlled algorithm?
Okay. I don't have the time that you want to hear because the tests were made with condition control. So we need to improve that experimental control because okay, I hope you can understand me. We need to change the proofs, the tests, as they are done, as we are done, once the drone is in flight. So the dynamics is very fast. So the delay produced by the camera is not affect our system, but we have already in flight. We need to do the proofs without the flight drone or to do from the beginning. I don't know if you can understand me.
Well, what I understand from where I am is that you can achieve the trajectories, but you cannot yet achieve the reaction time.
Yes.
Is that correct?
Yes.
Thank you. That is very interesting. Thank you.
Thank you.
Thank you, ma'am, for your presentation. Lastly, moving forward, I would like to invite the last presenter for the session, Fang Fang. Uh, uh, yes, I would like to invite you
Yeah,
to present a paper titled Multiplayer System, Fostering Emotional Interaction via EEG Data. Are you here, ma'am?
yes, thank you. I'll
Yeah,
share my screen.
yeah, just a second. Yes, you can share your screen.
I'll share my video.
It's visible, but there's no audio,
No sound.
no sound.
Thanks to the organizing committee is multiplayer system, fostering emotional interaction via EEG data. The paper explores a system designed for enhancing emotional connectivity through cooperative interactions and clear biofeedback, utilizing the Muse device for data collection and the Mind Monitor software for EEG data processing, along with Python for system development. This research investigates the potential of clear biofeedback to boost empathy within a multi-user cooperative setting by applying design science research methodology and examining the responses of 10 participants. This study establishes a link between EEG data and emotional experience, providing fresh insights into emotional interactions among multiple users. Its application in enhancing empathy within group collaborative environments is not as common. The study introduces an interactive tool that investigates explicit biofeedback's impact on emotional bonds through cooperative interactions. By distributing physiological data, like EEG, among users, it aims to foster shared understanding and emotional harmony, thereby enriching empathy and insights into collective emotional dynamics. This approach not only redefines interactive design, but also paves new paths for studying emotional exchanges and interpersonal connections. Research indicates EEG's efficiency in recognizing emotions, with an 86.97% accuracy using fuzzy integration data fusion. Studies have also delved into biofeedback's role in enhancing multiplayer systems user experience. For instance, Bacteria Hunt, an EEG-based multiplayer game. Neurobrush, a web app that encourages competitive art creation through BCI. This study investigates if explicit biofeedback in a collaborative setting can enhance empathy within a multi-user system. Key features of the experiment include 1. A dual-user wearable device for simultaneous experience. 2. Capturing participants' EEG waves. 3. Employing existing software for real-time aesthetic data visualization. 4. Data storage for future analysis. 5. Collecting user feedback through surveys and interviews. We detail the system's design, implementation, and testing processes, along with insights and conclusions. The hardware utilized is the Muse headband for EEG. Data transmission involves Wi-Fi LAN and OSC communication via Mind Monitor software, with data processing on a website developed using the Google Charts API, and interaction and visualization through Touch Designer software based on Python. The interaction and feedback process involved two participants, the questioner and the respondent, both equipped with EEG devices, headphones, and cameras, without direct interaction. The questioner's interface displayed the respondent's facial expressions, an emotion-triggering question selector, EEG visual effects, and guidelines, while the respondent saw the questioner's image and their EEG graphics. EEG visualizations showcased alpha, beta, purple pentagons, and theta waves, with sounds from the International Effective Digitized Sounds Library inducing emotions. The combination of scenes and sounds can somewhat affect the viewer, causing short-term emotional fluctuations. These can be identified by reading specific EEG data bands. For example, in the frontal lobe areas represented by the A73 and AF8 electrodes, an increase in beta waves, indicating a significant amount of scare-related information processing accompanied by fear and anxiety, is noticeable. Additionally, larger peaks of alpha waves, associated with relaxation, suggest a reduced level of relaxation after being scared. This study explores the application of explicit biofeedback in enhancing emotional cycles and empathy through designing and implementing a multi-user interactive system. Experiments with 10 participants using Muse EEG devices collected and analyzed brainwave data and emotional responses, showing improved emotional communication and understanding, highlighting the potential of explicit biofeedback in fostering emotional resonance. Despite insightful results, limitations include a small sample size, signal stability issues of Muse devices under certain conditions, and the complexity of interpreting EEG data. Future research requires larger samples, improved equipment and algorithms, and more detailed emotion and biofeedback analysis methods to enhance system accuracy and user experience. That's the end of my sharing. Thank you.
Okay, thank you.
Thank you, ma'am. Are there any questions?
Yes, I have one question. I will send it by chat.
Sure.
Yeah.
He's sending you a question through chat.
Please bear with me.
Okay.
Yes.
Maybe I can reply to you in text afterward. I think it's clearly that way.
Sorry for the accent. Can you write down the response, please?
Yes, yes.
Thank you.
Thank you.
Thank you, everyone. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chairs, Sir Professor Honji Veena Setan Rathel and Sir Jitendra Bhatia to be present with us throughout the session and for chairing the session. A token of appreciation to the chairs on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, everyone. In the end, I kindly request everyone to switch on their cameras for a quick snapshot of the virtual conference.
Thank you.
Can everyone else please switch on their cameras? Okay. Thank you, everyone. Just 1, 2, 3. Yes. Thank you for joining the session. Stay safe. Take care. Bye-bye.
Thank you. Bye.
Thank you.
Thank you.